Hello friends, welcome back to the channel. So here in today's video we will see how to solve the problem on distribution function. So here in the problem statement it was given the discrete variable, and these are the values taken by the discrete variable, and these are the corresponding probabilities taken by the discrete variable. So it was asked to plot its distribution function, and we have to find the probabilities from -1 less than x less than 3, and probability x less than 7, and probability x greater than or equal to -0.5. So in order to plot the distribution function, we have to find the distribution function for each value the random variable takes. So first, if you see, xi value starting value is -1. So first we have to find fx of xi is equal to -1. So what is the distribution function? Distribution function is nothing but probability of x less than or equal to xi. Probability of x less than or equal to xi. So here xi value is -1. So this is equal to probability of x less than or equal to -1. So we have only one value for less than -1. So probability of xi taking -1 is simply 0.1. So fx of xi at xi is equal to -1 is simply 0.1. So for the second point, xi is equal to -0.5. So fx of xi at xi is equal to -0.5. Similarly, this also we have to find probability of x less than or equal to xi. So that is equal to probability of x less than or equal to xi value is -0.5. So here we have two values of probability. One for less than -0.5, it is taking -1, and it also includes -0.5. So this will be sum of probability of x is equal to 0 -1, and the probability of x is equal to -0.5. So from the table we can see probability of x is equal to -1 is 0.1, and probability of x is equal to -0.5 is 0.2. So if we add, we will get 0.3. So probability of x less than -0.5 is simply 0.3. Next, we have to find fx of xi is equal to 0.7. xi is equal to 0.7. So that is equal to probability of x taking all the values less than 0.7. So this we can write it as, so there are three values as you can see, -1, -0.5, 0.5. So probability of x taking -1 plus probability of x taking -0.5 plus probability of x taking 0.7. So this in fact we can write it as fx of xi value at -0.5. So this we have calculated, this equal to 0.3. 0.1 plus 0.2 is equal to 0.3, and probability of x is equal to 0.7. From the table we can see it is 0.1. So 0.3 plus 0.1 is 0.4. Next, fx of xi value at 1.5. fx of xi value 1.5. So that is equal to probability of x less than or equal to 1.5, which includes probability of x is equal to -1 plus probability of x is equal to minus 0.5 plus probability of x is equal to 0.7 plus probability of x is equal to 1.5. So this we can write it as, these values we have already summed, it gives 0.4 plus probability of x is equal to 1.5. We can see from the table it is 0.4. So it will be another 0.4. So total it will be 0.8. So next, fx of xa value, it is taking 3. So that is equal to probability of capital X less than or equal to 3, which is nothing but probability of x is equal to minus 1 plus probability of x is equal to minus 0.5 plus probability of x is equal to 0.7 plus probability of x is equal to 1.5 plus probability of x is equal to 3. So which is equal to 0.8 plus probability of x is equal to 3. You can see from the table it is 0.2. So it is 0.2, that is equal to 1. So now substitute these values in the above table. So fx of x at xa is equal to 0.7, it is 0.4. Its value is 0.4, and fx of distribution function at xa is equal to 1.5. You can see it is 0.8. So it is 0.8, and fx of x at xa is equal to 3, it is 1. So now we got the values. Now we have to plot these values of the distribution function with respect to the values it is taking. It is nothing but the distribution plot. So at xi is equal to minus 1, at xi is equal to minus 1, it is taking 0.1. 0.1. So at xi is equal to minus 1, it is taking 0.1. Next, at xi is equal to 0.5, fx of xi value is 0.3. So it will, there will be a sudden jump. At xi is equal to minus 0.5, it will jump to 0.3. 0.3. So it will continue up to xi is equal to 0.7. Now at xi is equal to 0.7, its value is 0.4. So there will be jump of 0.1 at 0.7. It will continue till 1.5. At 1.5, its value is 0.8. So at 1.5, it will jump to 0.8. Next, so it will continue here up to at xi is equal to 3. At xi is equal to 3, its value is 1. So the maximum value the distribution function can take is 1. So this is verified from this. So this is the distribution plot for the given random variable, discrete random variable. As it is a discrete random variable, the plot is also discrete. It is not continuous. For at each value, there will be a sudden jump. So this is the distribution plot. So next we have to find probability. Second bit is probability of minus 1 less than x less than 3. Second bit is probability of minus 1 less than x less than 3. X less than 3. X less than 3. So if you observe the table from minus 1 to, it is not included less than or equal to. So we have to see the values between minus 1 to 3. So between minus 1 to 3, there are 3 values. So we will copy this table. So if you see between minus 1 to 3, we have between minus 1 to between minus 1 to 3 we have three values. So it includes probability of x is equal to minus 0.5 plus probability of x is equal to 0.7 plus probability of x is equal to 1.5. So these three values lies in the range minus 1 to 3. So probability of x is equal to minus 0.5, from the table we can see its value is 0.2, and probability of x is equal to 0.7 is 0.1 plus probability of x is equal to 1.5 is 0.4. So if we add the three values, it is 0.7. So probability of the random variable x taking values between minus 1 to 3 is 0.7. Next, C bit. So it is given probability of x less than 0.7. It is given C bit is probability of x less than 0.7. So as you can observe, less than 7 there are two values. The xi is taking minus 1 and xi is taking 0.5. So only two are there. So probability of x is equal to minus 1 plus probability of x is equal to minus 0.5. So probability of x is equal to minus 1 is simply 0.1, and probability of x is equal to minus 0.5 is 0.2. So which is equal to 0.3. So probability of the random variable x is taking values less than 0.7 is simply 0.3. And the last bit is probability of x greater than or equal to minus 0.5. Probability of x greater than or equal to minus 0.5. So this we can solve in two ways. The easiest one is, it was asked greater than or equal to 0.5. So this we can write sum of two total values that it is taking. We can write total values 1 plus of sorry. So this we can write it as probability of x greater than minus 0.5. We can write it as 1 minus of probability of x less than 0.5. So this we can write sum of the two sample points. So which total sum is 1. Probability of x greater than minus 0.5, we can write it as 1 minus probability of x less than 0.5. Less than 0.5 we have only one value, which is nothing but probability of x taking minus 1. Probability of x taking minus 1 is 1 minus 0.1, that is equal to 0.9. Or the other way is probability of x greater than or equal to minus 0.5. We can write it as probability of x taking minus 0.5 plus probability of x taking 0.7 plus probability of x taking 1.5 plus probability of x taking 3. So even if we sum x probability of x taking minus 0.5, it is simply 0.2, and probability of x is equal to 0.7, it is 0.1. Probability of x taking 1.5 is 0.4, and probability of x taking 3 is 0.2. So if we add 0.2 plus 0.1, 0.3 plus 0.4 is 0.7 plus 0.2 is 0.9. So you can do either way. So this is how we have to solve the problem on distribution function. I hope everyone is understood. If you have any questions, you can comment in the comment section. I will reply to your questions. So thank you for watching. please subscribe to my channel and share with your friends and classmates. Thank you.